Okay, folks, here is part two of week two, and chapter six or chapters 6 and 7 will be our look at inferential statistics. And those of you who had an undergraduate course in statistics, you know this is typically the portion of the course that follows probability. And if you've had this course before, this idea of confidence intervals and hypothesis testing should be fairly straightforward. If you have not had this course before, again, we talk about this idea of sampling distributions and the central limit theorem, and that's really what you see here is applications of those two ideas to help us infer something about a population based on a sample. And that's really kind of where the value of statistics comes in as a discipline. So let's talk about these two ideas. The first will be chapter 6, which is confidence intervals. So you've got some data here. It looks like it's attendance data from baseball stadium, San Francisco Giants and Oakland A's out in the Bay Area of California. Looks like we've got some San Francisco Giants data from 58 to 68. And then let's see, Giants plus A's over in Oakland from 69 to 78. And what we're trying to do is come up with confidence intervals for the actual parameter, the actual attendance, based on these two samples. So we're going to do these separately. When it gets down to talking about the details of the confidence interval, I'm going to focus on this first set of data from 58 to 68. But what I want to do first is kind of reinforce what we talked about in the reading, and that is what is a confidence interval. And so the construct of a confidence interval, again, is a lower and upper bound by which we have some confidence that the actual parameter that we're trying to estimate is within that range. And the confidence interval construct, regardless of whatever type you're dealing with, whether it be a mean or a proportion, is a point estimate plus or minus a margin of error. And in this case, since we're dealing with sample means from each year, mean attendance, the equation that you want to look at, I'll detail it here for you, but the equation that I'm using here is equation 6.3 in chapter 6. And again, what you'll see in there is a couple things. Number one, we're estimating a population mean, and we're doing it based on the fact that we do not have the population standard deviation. So that's going to invoke the use of the t distribution versus the z distribution and a slightly a modified computation of the standard error of the mean based on the fact that we only have the sample standard deviation. So in this case, the point estimate will be the average attendance. So as you get started on your confidence interval, the first thing you need is a point estimate, and that is just the average attendance for these first 10 years of data that you have. So that will be your point estimate, again, just finding the average. And then the margin of error. I'll talk a little bit more about this t-critical value in just a second, but the standard error of the mean, which is basically the standard deviation of this sampling distribution for which this set of data falls, will just simply be the sample standard deviation divided by the square root of the number of observations you have. And I believe you have 10 years worth of data here. Again, I mentioned the fact that this is a t distribution problem, not a z distribution problem, because you're dealing with the sample standard deviation, not the population standard deviation. And we understand the difference between the z distribution and the t distribution in this case. And so we'll assume a bit more variation here because we don't know the population standard deviation. So remember that the t distribution is based off a number of degrees of freedom, and that's basically related to the sample size. So as we look at this first set of data, N1, so the number of data points that you have in this first set of data is 10. So again, when we look at the number of degrees of freedom that would be associated with this problem, it would be n minus 1. So you're looking at a t distribution here with 9 degrees of freedom. So to find the t critical value here, and again, what that's going to tell you is the number of standard deviations by which you're going to develop a 95% confidence interval. So basically, if you look at the construct, you'll take the average attendance, and what you'll do is you'll subtract the margin of error, which is this t critical, again, in this case, effectively some number of these standard deviations that we'll subtract from the point estimate, and then we'll add the exact same number of standard deviations times standard deviations. Let me go back and say that again. Some number of standard deviations, and again, standard deviations of this size. So it's nice that you can use Excel to find this t critical value. What I have computed in this cell is this formula that I show you right here. So you'll see what I'm querying Excel for is the t inverse in this first entry, or this first entry here, 0.025 is the probability. 0.025, I'll explain that in just a second, with 9 degrees of freedom. So if I'm looking for the middle 95% of the distribution here, which again really kind of tells me how many standard deviations each side of the mean with 9 degrees of freedom, this 0.025 is telling me that I've left basically 2.5% of the distribution in the bottom half of the distribution and 2.5% of the distribution in the upper part of the distribution. So 2.5% plus 2.5% is 5%. And if I add that to 95%, I've considered the entire distribution. And so if I ask Excel for this t distribution or this t inverse, it's going to give me a t value or a t critical value, again, where I leave 2.5% in. Effectively, if you see this negative number, let me just say, what I'm asking it for here is this t critical value in the bottom half of the distribution, because I'm leaving 2.5% to the far left and I'm separating that from the upper 97.5%. So that t critical value is minus 2.26. And because of the symmetry of this curve, if I were to say equals t inverse 0.975, where I have the lower 97.5% separated from the upper 2.5%, you would get the exact same value. It only would be positive because, again, it's to the right of the mean. So the construct for your interval here, for your confidence interval, will be your point estimate, whatever you come up with for the average, plus or minus the margin of error. When you substitute the margin of error, it doesn't matter if you use negative or positive, because at one point you'll take the negative of the negative, which would give you a positive, and then a positive of a negative would give you the negative. So the bottom line is point estimate plus or minus the margin of error, which would be this t critical value times the sample standard deviation divided by the square root of 10. And again, if you there's good details in the book. And again, look at an equation 6.3. This should get you going and get you finished up. And then you're going to do the exact same thing for the other set of data, 11 data points. You're just going to go back through. You'll compute your point estimate. You'll go back and you'll compute your sample standard deviation. And then you'll have to use this Excel function. The only difference will be, since you have 11 data points, you will have 10 degrees of freedom, not 9. So that is that should get you well into your work on problem, or the chapter 6 problem. Chapter 7, hypothesis testing. So we've got some information here on hotel rooms, 25 hotels, 100 rooms. So a sample of 2,500 data points here. And what you're looking to test here is whether or not the percentage of non-conforming rooms is less than 2%. So as you go through and you look at what it is you need to do here, the first thing we always do in hypothesis testing, and probably the most challenging portion, is to set up the hypotheses. Now, what I have done here, no tricks, what I have done is I have set up the null hypothesis with the population proportion, which is represented by pi. And so the sign here that I've helped you with is greater than or equal to. And I think the value you want here, I'm not going to say it, but I'm giving you a pretty good hint, should be, if you convert this value to a decimal, that should be your null hypothesis. And then what you're going to test is, have they done well enough to say that the percentage of non-conforming rooms is below 2%. So clearly this is a one-tail left test, and you're testing at the 0.05 level of significance. So alpha here is going to be 0.05. The z critical value, again, if you're looking at this from a rejection region standpoint, you can also compute the p-value if you want to. Might be simplest to use the rejection region. So effectively, if and again, here's an Excel formula. In this case, I want again, similar to what we did on the t-distribution, only in this case it is a z-critical value because we're using a proportion. Norm.s, or normal, standard normal, inverse, 0.05. Again, so what this formula is doing for you here is it's breaking the distribution into the bottom 5% of the data from the upper 95% of the data. And so that z critical value for you is going to be negative 1.645. So anything, once you go compute your test statistic, I'll talk a little bit more about, well, let me just talk about that before I get too deep into what I'm saying here about drawing the conclusion. So you're going to have to compute your test statistic. If you look at equation 7.3 in the textbook for a proportion, that will explain to you exactly how you're going to do that. Let me just be very clear about a couple things in that equation. Your p-hat value that's shown in that equation will be the number of non-conforming rooms divided by 2,500. So the number of non-conforming rooms is here in column W. If you add that up, divide it by 2,500, that will be your p-hat. And what I'm saying here is write that proportion to 3 decimal places. If you don't, I think it'll be the same as 0.02. But once you see that value, I think you're going to see right away what the conclusion is here. But just make sure you convert that, or you write that to 3 decimal places so you see your p-hat value. Pi naught is equal to the pi value that you will use here. And again, I'm giving you a pretty good hint on what that pi value is going to be assumed to be in your null hypothesis. So then you can compute your test statistic, and then you can draw your conclusion. And I think, again, if you draw a standard normal distribution and you draw the z critical value at minus 1.645, and of course then everything to the left of that would be your rejection region, and then you will be able to see that your or your test statistic will fall somewhere in that distribution. Very likely you will find that it is not in the rejection region, and that will allow you to state your conclusion. And again, the conclusion will either be, and it's always in terms of the null hypothesis, that there is enough data to assume that you can reject the null hypothesis, you can reject H naught and assume the alternative, or if the test statistic does not fall in the rejection region, the conclusion will be that you will fail to reject H naught, and say that there is not enough evidence in the data that you have collected to assume that you have done a better job about producing rooms that are non-conforming. So I hope that's helpful. Again, what I typically say about hypothesis testing is the most challenging part is right here, and that is setting up your hypotheses and understanding how you will reject the null hypothesis if the data is statistically significant. The level of significance here is important because that helps you set up and find your z critical value. Again, what I have, and this is the equation. I didn't know if you could see it, so I just typed it in this cell so it's nice and big and everybody's able to see how you're going to generate this value from Excel. Again, once you have done all that, it's then just a matter of computing the test statistic. Once again, since you're working with a proportion, this is equation 7.3 in chapter 7. And just to make sure you're clear on what that notation is, I tell you how to compute p-hat, and then for pi 0 or pi naught, you'll be using basically the value of pi that you are assuming right here. And I will tell you one more time, if you go back to that, you will be very clear on what that is. The only other sticking point that might be here is, there might be an inclination to use the number of samples at 25. But remember, you've got 100 hotel or 100 rooms per hotel. So 25 times 100 or 2,500 is your value of n here, and that's will be used. Hopefully that makes this clear on computing p-hat. So I hope these are helpful. Again, I broke this up into two. Since the inferential statistics, I don't want to rush through that with some of the other things we did on the questions in chapter 5. So hopefully these are helpful. If there's anything I can do to assist you, please don't be afraid to reach out, and I look forward to seeing your work. Take care.